Okay, our 7-2 is all about the distance formula and the midpoint formula. So we're going to find the distance between 2 points either on a number line or a coordinate plane, or we're going to find the coordinates of a midpoint either on a number line or in the coordinate plane, or on the coordinate plane. Okay, so we're going to use this number line to find each measure. We can either just simply count from A to C and find that that's 7, or we can use an absolute value to ensure that we get a positive answer, and we can say -4 minus, this is a 3, gives us a -7, and the absolute value of -7 is 7. And the reason why we use an absolute value is because this distance has to be positive. Okay, or on B, we can go back to just counting. From C to E, we go from 3 to 11, so that is a distance of 8, or we could take 3 minus 11 and take the absolute value, which would give us -8, so our distance is 8. And then on from B to D, it goes from 1 to 7, so we can go 1, how about -1? -1 to 7, you can go -1 minus 7, we get -8 there. And the absolute value of -8 is 8. Or you could just simply count from B to D. The distance formula, this is based on the Pythagorean theorem, and it's a formula that is used to find the distance between any 2 points on a coordinate plane. So if I give you now a coordinate plane and say find the distance between these 2 points A and B, then we're going to use what's called the distance formula. We recently learned how to find those points or find that value, and I'm going to look over here at this picture we have here, and recently we used what was called the Pythagorean theorem. If this was on a coordinate plane, this distance would be very easy to measure. We would call it A, and as would this, because we could just count those measures. It's like counting on the number line on the previous example. And then because we're trying to find this distance here, the length or the measure between those 2 points, we could take A squared plus B squared equals C squared. So if we did have it graphed already, this is an option of actually finding the length from A to B. Or we can use the distance formula, which says that we take x2 minus x1 squared and add y2 minus y1 square that, and add those two values and then take the square root, and that will give you the distance. So in example 2, we're going to find the distance. So instead of graphing these, we're going to go ahead and use that formula. We're going to take -2, which is our y2, minus our x2 minus our x1, which is 8, square it. And then we'll take our y2, 3, and minus a -20. So that will become plus 20. And then we'll square that. Now we just simplify this. -2 minus 8 is -10. 3 plus 20 is 23. Then we take -10 squared is 100, plus 23 squared is 529. We add those together, we get 629, and then we talked about simplifying this radical. We're going to try to break it down. It breaks down to 17 times 37, and we can see that both these two numbers are prime, which means that we cannot break down that radical. So we're going to just leave our answer as the square root of 629. Okay, moving on to the second one, just another example of applying the distance formula. We'll take our, starting with that x2 value, 4, and subtract our x1 value. So minus a -4 would become plus 4. Then we're going to take our y2 values and subtract our y1 value and square it. So we get 4 plus 4, which is 8 squared, plus 17 minus 2 is 15 squared, and 8 squared is 64, plus 15 squared, 225. We add those two values, and we get 289. And then I would just go ahead and take the square root to see if it is a perfect square, because I do know that that is a perfect square. It is 17. And initially we talk about this being a plus or minus 17, but because we're talking about distance, it can never be negative. So we just ignore the plus or minus option and just say that distance is 17. Okay, on example 3, it wants you to find the midpoint of each segment. We can do what we did with medians doing statistics. We can start at K and M and start crossing them off until we get to the middle. And we can see that the middle here is 2. Or another method is to add the coordinates -2 plus 6 of K and M and divide by 2. So we can add those two values and take an average of those two. So -2 plus 6 is 4, divided by 2 is 2. Okay, from L to N, we can either just cross them out until we get to the middle. We can kind of see that 6 is right in the middle. Or you could add the coordinates of L. L is at 3 plus N, which is at 9. That'll give you 12 divided by 2 is 6. And then from L to M, that's pretty easy. It's close together. You can see the middle is right, well, close, right about there. So we're going to say it's between 4 and 5, so that would put it at 4.5. Or you could add L, which was 3, and add M, 6. So those added together are 9 divided by 2 gives you 4.5. The midpoint is a point that bisects a segment giving two equal segments, and we actually did a problem of the day that involved a midpoint. And so here we have this segment, and what this says is that if we have the midpoint at B, that it cuts AC in half so that from B to C is the same as from A to B. So those are equal. So if this was 10, this would be 10. So it tells us that AB, the length from A to B, is equal to the length from B to C. The midpoint formula is an average, and we use that on the last example, of the endpoints. So if the endpoints are in the coordinate plane so that we have these 2 points, then the formula will look like this. We add the 2 and divide by 2. We add the x values to divide by 2, add the y values to divide by 2. And I just want to reiterate that it is an average. We add and divide by 2 of the 2 points. Example 4 asks us to find the midpoint of the segment. So we could graph these, and over 8 down 20, and over 2 up 3, and draw this, and then find this midpoint here. But it's, I think, a lot faster just to use our formula. So with our formula, we take our midpoint is equal to x1 plus x2. So x1 is our 8, x2 is our -2, and divide by 2. And we do the same thing with our y1 is -20 plus y2, and divide by 2. So we'll go ahead and simplify that. 8 plus -2 is 6 over 2. -20 plus 3 is -17 over 2. And we'll go ahead and simplify those. And 6 divided by 2 is 3, and -17 divided by 2 is -8.5. Okay, we'll go moving on to B. We'll do the same idea for our midpoint. We take our x1, -4, and add 4, divide by 2. And we take this 2, our y1, and add y2, and divide by 2. So we get -4 plus 4 is 0. 2 plus 17 is 19. And if we take 0 and divide by 2, we get 0. 19 divided by 2 is 9.5. So you could either say 9.5 or 9.5. Either one will be acceptable. Example 5, we're given a segment in the coordinate plane RT, and we're given that S is the midpoint. Okay, but here if you notice they only give us segment or points R and S, and we have to find T. So the way that I'm going to show you how to find T is, if you notice on the last one I said the midpoint is, and we know that the midpoint is S, so I'm going to say -2, 2 is our x1, if we call that R, then T has to be our x2. So 2 plus x2 divided by 2, and then our y1 would be the 8 plus our y2 would be the one value from T. So y2 here divided by 2. And then from here we're going to go ahead and, because this is an x value and this represents an x value, we're going to set them equal. So -2 equals 2 plus x sub 2 divided by 2. And then we'll solve that. To solve that, we're going to go ahead and get rid of this 2, so we'll do it by multiplying by 2. -2 times 2 will give us -4, and these two will divide out. That was Carrie. Anyway, trying to finish this, we will go ahead and subtract 2 to both sides, and we get -6 equals x sub 2. Okay, so we're going to do the same thing with our y's. We're going to set our y values equal. So we have a 2 from that ordered pair is equal to 8 plus y sub 2 divided by 2. And then we'll follow that same process. We'll eliminate this 2. To eliminate it, we multiply by 2, and those will divide out. So we get 2 times 2 on the left equals 4, and 8 plus y sub 2 on the right. We subtract our 8, and we get -4 equals y sub 2. So we then have our ordered pair, T, at -6, -4. Alright, I hope this helps. Good luck with your assignment, 7-2, the distance formula and the midpoint formula.